Okay, so week 9, lesson 4 is on graphing absolute value graphs. So what we're going to do is we're going to start by graphing the function, and then we'll take the absolute value and you'll see what happens. So for y equals x, this is just your basic line with a y-intercept of 0 and a slope of 1. Okay, we've been using this example a lot lately. Okay, so it's just this line. Now, the difference between the one over here on the left and this one over here on the right is the absolute value, which means that you cannot have a negative, right? Absolute value means everything ends up being positive. So all this part of the line that has a negative value, right? A negative y value has to be made positive. So all the stuff that's above the x-axis remains the same, right? Or equal to 0. Right? All of this remains the same as it was over here. And these points end up becoming their positive sort of counterparts. So the part that was at -1 is now at +1. And what was at -2 is now at +2, etc. So anything that was under the x-axis, right? All the stuff that was under the x-axis right here ends up reflecting over the x-axis so that it ends up being positive. Okay, so the domain is from -infinity to +infinity. And the range, again, the range has to be positive, and I shouldn't have written that bracket that direction. It's allowed to equal 0, inclusive, and the it goes all the way to infinity, but non-inclusive. Okay, so let's take a look then at this next example. Let me move it up a little bit. Okay, so this line has an intercept of 4, 1, 2, 3, 4, and a slope of 2. Right, so it looks like this. Okay, so when we go to graph the absolute value of it, all you have to really think about is the fact that from here down is negative. Okay, the absolute value is going to make all those points positive. So this, I should change colors. This will remain the same, right? All of this that was already positive doesn't change. It's this part that gets reflected back over and ends up looking like this. Okay, and the domain ends up being from -infinity to +infinity, and the range goes from 0 to infinity. Now, something else to think about on this problem is that you can factor a 2 out of that. 2 times x plus 2. And you're also allowed to separate that into the absolute value of 2 times the absolute value of x plus 2. And then some of the rules that you've been learning lately still come into play. Meaning, this is twice as tall, right? Each of these points is twice as far from the x-axis as it was before, and the entire v has been moved to the left 2 units. Okay, and the reason I'm showing you that on that example is because it ends up being kind of important on the next example. So let me move this up and let's get to that next example. Okay, so for this line, it has an intercept of -1 and a slope of 1. So the original looks like this. Okay. Now you may be saying to yourself, well, this doesn't really look like it has this in it. But let's factor it, and you might see it happen. Okay, so if I factor and I take out a -2, I would end up with x minus 1. And if I separate the stuff that's inside the absolute value into 2 separate absolute values, and then the absolute value of this 2, I'm going to write it down here because I need a little bit more room. You end up with 2 x minus 1 plus 1. Okay, so let's do this graphically. Okay, let's do this graphically, which would mean first I'm going to graph the absolute value of x minus 1. Okay, because I know the x minus 1 and I can do the absolute value of it, it looks like this. And I'm just going to put some dots in. Positive stuff, and then this gets reflected. I'm going to switch colors. Second, I'm going to do 2 times the absolute value, which means these all have to double in height. Double in height. All right, and then third, it all moves up 1, right? Every ordered pair moves up 1. So this red one now moves up 1, that moves up 1, up 1. So if you think about, and hopefully you remember this should have been moved to the right 1, up 1, and be twice as tall. So you can see it's been moved right 1, up 1, and the slopes are 2. So we're looking at this blue graph, which has a domain that goes from negative infinity to infinity, and a range that goes from 1, right? The lowest value here is at 1 all the way to infinity. All right, let's take a look at the next page. Okay, so this graph is a parabola. If I factor, then I can tell easily where the zeros are. They're at 0 and at 1, 2, 3, at 4. I know where the axis of symmetry is. 1, 2, 3. So that means I know exactly where the vertex is. There's a couple more ordered pairs. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So here's some really nice ordered pairs for this parabola. Okay, so when I go to the next one over, when I try to do the absolute value, anything that's 0 or above stays exactly where it was. 1, 2, 3. Okay, so this part stays exactly where it was. It's this stuff down below, down here, that has to be made positive. It's literally just going to sort of fold up and over like this so that it becomes positive. So let me take those ordered pairs and just flip them over. So this point here ends up being 3 up. This is the vertex that's now been reflected up, and here's the other point. And again, it has sort of a curve to it like this. And again, you can tell that the only thing that's happened is these values that are negative have been made positive. The domain is from negative infinity to positive infinity, and the range goes from 0 to infinity. Okay, let me scoot this up. Okay, so this stuff in here is a parabola. It has a vertex at 3, negative 8. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. And it's twice as tall as a regular parabola. 1, 2, 3, 8. And then 16 for the next one. No. 18. So I think it ends up being at the top, right here. Okay. All right. So now, I'm not concerned with any of this part or this part of the parabola because they're already positive. It's the other parts, right, that need to come into the positive area, which would be here and here, right? I just reflected them over, and it looks like this. All right? And then this, you've definitely seen this before, right? And again, I could do it the way we just showed, but you know that this is an absolute value graph with a vertex at 4, 1, 2, 3, 4, negative 3. All right, and there is that graph.